Over 45 billion years ago, the Sun was born, surrounded by a protoplanetary disk of gas and dust. In this disk, particles collide, forming larger objects, planetesimals. Collisions between planetesimals give rise to protoplanets, the embryos of future planets. In its early stages, the solar system was a dynamic battlefield of millions of bodies. Among these bodies, a hypothetical object is forming, Theia, a future participant in a dramatic collision. Theia is gaining mass, moving along an unstable orbit that will eventually collide with the young Earth. At that moment, Earth was a hot molten sphere, still without an atmosphere or water. Millions of years of chaotic motion lead to the inevitable, a collision course. The giant collision changes Earth's history forever. It is an event of planetary scale. Debris from the collision forms a ring of material around Earth, the beginning of the Moon's birth. The space debris left after the collision gradually forms a ring around Earth. Gravity begins to gather the debris into dense clumps, the first steps toward the birth of a satellite. From this chaos, a new celestial object emerges, the future Moon. The young Moon quickly cools down, forming a rocky shell. At that time, Earth was a scorching hell without life or atmosphere. After the collision, Earth's surface remains liquid. It is the era of giant volcanic processes. Meteorites bring the first water molecules, forming a steam envelope around the planet. The first traces of the atmosphere are water vapor, forming dense, opaque clouds. The rains falling on the scorching Earth evaporate instantly. The struggle for cooling continues. The surface cools enough for the first solid sections of the Earth's crust to appear. Earth gradually transitions from magmatic chaos to a stable, solid crust. As cooling progresses, the first signs of liquid water appear, the beginning of ocean formation. The young planet begins to take on familiar features. Oceans, clouds, and volcanic activity appear. At this time, the Moon is located much closer to Earth than we see it today. The Moon's gravity causes powerful tides. They shape the landscape and influence the oceans. Eruptions release carbon dioxide, water vapor, and other gases, the foundation of the future atmosphere. A protective atmosphere gradually forms, allowing heat and water to be retained. Earth continues to be bombarded by asteroids, supplying the planet with valuable elements. The cosmic environment remains dangerous. Earth is still in a zone of intense bombardment. The first stable continental masses form, the embryos of future continents. Earth's surface is still young and active. Volcanoes leave their mark on the planet's formation. The atmosphere is saturated with energy. Lightning charges molecules, triggering chemical reactions. Molecules in the primordial ocean undergo changes under the influence of lightning and heat, the foundation of life. Hydrothermal vents on the ocean floor enrich the water with minerals and heat. The Moon stabilizes Earth's rotation. This is critical for the formation of a favorable climate. The collision that nearly destroyed Earth ultimately gave rise to a unique planetary pair. Earth becomes more stable. The climate and landscape we recognize today begin to take shape. Oceans and the atmosphere begin to reshape the landscape. geological diversity emerges. The movement of tectonic plates triggers mountain formation and the transformation of the planet's surface. The first mountain ranges rise from the ocean depths. Earth begins to take shape. Volcanism creates new areas of land. The landmass expands. Hydrothermal activity remains a powerful driver of geological changes. Water not only cools the earth, it shapes valleys, rivers, and lakes. Minerals are forming deep within the earth, destined to become resources for future biodiversity. Every drop of water is a step toward creating an environment suitable for life. Sunlight and water create unique conditions. Earth is preparing for a new stage. In the depths of the ocean, complex chemistry begins, the foundation for the formation of organic molecules. Simple organic molecules, the building blocks of life, form in the primordial soup. Hydrothermal vents, an environment where the first life structures could have emerged. Enclosed structures, precursors to cells, provide isolation and metabolic exchange. Light, minerals, and water, three components that sparked the emergence of life. The first self-replicating molecules, a key moment in the transition from chemistry to biology. In natural conditions, molecules capable of interacting and evolving concentrate. The natural energy of volcanoes sustains chemical activity in water and on land. Light cycles initiate rhythms that influence chemical and biological processes. Our planet is gradually becoming an environment capable of supporting life in various forms. Cells, the foundation of all living things, emerge from simple organic compounds. Some cells learn to harness sunlight. Photosynthesis transforms the atmosphere. For the first time in Earth's history, oxygen begins to appear in the atmosphere thanks to living organisms. Earth is changing. With every drop of life, it becomes more complex and dynamic. Microorganisms form biofilms, the first ecosystems at the boundary between water and land. Traces of the first oxygen are preserved in the form of reddish sedimentary rocks on the ocean floor. Shallow waters are the ideal environment for life that requires light and stability. The moon is gradually moving away. This affects the length of the day and Earth's geophysics. In those times, a day on Earth lasted less than 10 hours. The rotation was faster. The atmosphere becomes more enriched, an important stage in creating favorable conditions for life. Solar energy is the driving force behind all physical, chemical, and biological processes on the planet. The first forms of life not only survive, but also begin to evolve. Genetic mutations become the foundation for natural selection and evolutionary development. Places with high concentrations of nutrients turn into biological hubs. Even in the most extreme conditions, life finds ways to exist. The planet born from collision now pulses with life and change. From simple cells arise colonies, the first steps toward multicellular life. Cyanobacteria are microorganisms that began altering Earth's atmosphere with oxygen. Dead microorganisms create the first biogenic sediments, preserving traces of life. Life continues to grow more complex. New forms and mechanisms of existence emerge. Phytoplankton, the foundation of the ocean food chain and a source of oxygen for the atmosphere. After millions of years of photosynthesis, the atmosphere becomes saturated with oxygen. Iron in the oceans reacts with oxygen, forming bright sediments, witnesses of change. Stone archives hold evidence of the earliest forms of life on the planet. The continents are gradually shifting. The Earth's dynamics have been ongoing since the very beginning. An ozone shield is forming, a protection that allows life to move beyond the ocean. Life emerges from the ocean onto land for the first time, a decisive step in evolution. Algae colonize the land, creating a new environment for other forms of life. Life adapts to new conditions, demonstrating remarkable flexibility. Cells with a nucleus appear, the foundation for more complex forms of life. Complex biochemical processes occur inside eukaryotic cells. The cooperation of cells leads to the emergence of multicellular beings. The first multicellular organisms, a turning point in the biological history of the planet. Life takes on numerous forms, adapting to various living conditions. The accumulation of oxygen changes not only the atmosphere, but also the chemical composition of the oceans. Changes in the atmosphere leave traces in the Earth's geological record. Ancient stromatolites, living structures that helped produce oxygen. Microbial mats play a key role in stabilizing shorelines and cycling nutrients. Even the simplest cells are capable of communicating and coordinating their actions. Algae photosynthesis, a source of energy and oxygen for many living beings. Unique communities form around geysers. Life adapts to extremes. The entire modern biosphere shares a common origin from a single ancient ancestor. Life transforms the appearance of the planet. The biosphere shapes the global balance. The rotation of the planet ensures an even distribution of heat and light. Each sunrise is a continuation of the story of a living planet that began in chaos. The harmony of the elements is the result of billions of years of interaction between matter, energy, and life. Life on our planet began with water, the cradle of evolution and diversity. Phytoplankton, tiny yet powerful oxygen producers and the foundation of food chains. Even rain traces in stone can tell more about ancient Earth than it seems. Plate tectonics shapes the outlines of oceans and continents we know today. A planet that began as a ball of fire became a home to billions of forms of life. A cosmic collision did not destroy. It became a beginning. Thus, our planet was born. Subscribe to explore the history of Earth's evolution with us.